as we begin. Today we're going to be matching graphs to stories. So thinking about the situation. And in this situation, we are talking about time and distance. Which one of these makes no sense at all when you read through what Tom was doing in situation A, B, and C? Because what we were asked to do is look at the graph and choose which story matches. Be sure you have at least 2 reasons to support your answer. So this is what you're going to be doing as we look at going through our notes today. So which one of these, raise your hand, has nothing to do with time and distance, would you say? Is there one? Rowan, which one do you see? You which one? You think C. Went for a jog, at the end of the road, he bumped into a friend, he slowed his pace. You think it matches or doesn't match? It does or does not? So this is time. And we are looking at this one. I want you to look at situation B. Situation B says he rode his bike east from his home up a steep hill. Does this have anything to do with how high you're going in elevation, this graph? This deals with time, possibly in minutes, could be seconds, and this is your distance from home. So right here, this is at 0, 0, this is when you are at home. But now you're going farther from home. Does that have anything to do with going up a steep hill? B is the one we should have not chosen at all. But now we want to go between A and C. And in A, it says that he takes his dog for a walk to the park. He sets off slowly. Is this going slowly or is this one going slowly? If we look at this as part A, B, and C, and we probably shouldn't use A and B because that's in our, so we'll use part X, Y, and Z of our graph. Where is he going faster, in X, Y, or Z? The fastest is probably Z and X, right? Y is the slowest, right? That's our flattest, right? So if we go back to what we were doing before break, when a line is flatter, you're not going as fast. It has less of a slope, right? So actually, the situation for this one should be C and not A as you are looking at it. So please circle C as you are looking at that one. One of our reasons would be what? What matches? Because why? Like, you got to be more specific.
He went for a jog, so at X he was jogging.
Is he going fast or slow?
Apparently so pretty fast.
Got it. Kind of fast, but not too fast, right? So you're jogging, you're not walking. So X is our jog, as we are looking at that. And then what happened? He bumped into a friend, and then what did he do?
His pace slowed.
Yeah, so at Y, we're going slower. Y is slower if we are looking at that, right? Because he's met up with a friend. So you need to be able to give me at least 1 or 2 reasons why you choose the one that you are choosing, okay? So as we look at that next page going down, you have 4 graphs, and you have actually 5 situations. So obviously when we match them, there's going to be one that doesn't match one of the situations. I want you to take a look at the axes. You have time across the bottom. That's our independent variable. Our dependent variable is distance from home. So what I would like you to do right now is we're just going to read through the situations, okay? So I'm just going to pick on someone and we're going to just keep reading these. So it says match the graph to the statement. One statement has no match. So if you would start off, Bashir. Yep, just read.
Tom went out for a walk with some friends. He suddenly realized that he left his wallet behind. He ran home to go get it and then had to run to pick up the fields.
Okay, so thinking about that one. Sam, run and read number 2.
Tom walked slowly along the road. He stopped to look at the time on his phone and realized he's late. And then he said he would.
Okay. If we look at number 3, if you are reading that one, Audrey. If we are looking, Hunter, at number 4.
Tom ran from his home to the bus stop and realized he missed the bus to the home.
Okay, and as we look at that last one, as we are reading that, what would we have for that last one as you read it? Do you want to go ahead and read it, Ren?
Tom walked to the store and he grabbed vitamin paper and ran away from home.
So which of these do we think has no match? Which one doesn't make sense for time and distance from home?
3.
3? Anyone think anything other than 3 that doesn't deal with home and the distance how far we are from home? 3 is going to be our no match. Okay, so let's think about that first, as that one doesn't make sense. He's opposite Tom's home is a hill. He climbed up the hill. These don't have anything to do with climbing up. They talk about your distance from home. So that one is why it's a non-match. Okay? So if we look at 1, he's walking to meet his friends. He realized he left his wallet at home. He ran home to get his wallet, had to catch up. Anyone have an idea? Want to give it a try? Jordan, what are you thinking? Any idea? D? The reason D might be is that he ran, he got, as he got there, he suddenly realized he went back home. He didn't stop for very long, right? Okay. Whereas this one, what's happening in 2? He leaves his house, right? So all of them are leaving. Do we think it's A, B, or C for this one?
A.
If we think about number 2, he slowly walked. This is the slowly. Looked at his phone and then started hurrying. So we want to think of A for that one, right? So now we want to look at the next one. As you are looking at that next one, what do you think, Nolan? For number 4. Which one? C. Because why? Why different from C than B?
Because C from 4 says that he ran and he went faster.
So here we're walking, right? And here we are running. So C, steeper, right? Graph means that we are going faster, right? So this was our run. Whereas if we are looking at this one, this is where we were walking, right? So where he walked to the store. So I agree this one probably should be B. So you need to be able to give a reason each time. So as you look at the top of the next page, distance from home. So here we're starting at home, Are we starting at home here? Definitely not. And this one we're starting at home. The only one that we're reaching home in is C, we get to home. And in A, B, and D, we're staying far away from home if we are looking at that. Patrick, would you please start reading start reading number 1?
After the party, Tom walks slowly all the way home.
Okay, Luden, want to read number 2?
Tom left his home for a run, but he was not very fit, so he gradually slowed down as he went.
Okay, Joseph, want to keep going?
Tom was running to his friend's house because he was late. Right when he
Yeah, that should be when.
arrived, he realized he dropped his phone along the way. So he ran back about halfway, found it, and he ran back to his friend's house.
Okay, so we're reading number 4 as we look at that one, Kaylin. And if we are looking at number 5, go ahead and read that one, Wyatt. So, as we look at this one, are we thinking which one has no match? So if we are looking at the first one, after the party, Tom slowly walked all the way home. So let's look at that one. What letter? Please write a letter down. I want everyone to write a letter for that first one. Put a letter right now. Put a letter if you haven't done so. If we are looking at that first one, we think it probably should be C. Slowly going home. This one says he left his home for a run, but he's not very fit, so he gradually, slowly made his run. Which one looks like he's not very fit? Probably, we look at that one. Does no match make sense? Could you say D for this one? And in this case, I just want you to take a look as we are looking at this. Tom says, the next one says he's running. Then he's going to go, which one makes sense that he has to drop his phone, where it goes close back to home? A, B, or D is what we have left. A, probably, right? If we think of A, does that make sense that he's going to go back? This is where he picks it up and then takes off running again, right? So we're going to continue with that last one, the last two. The graph is just wrong if we are looking at this. Which one says he's in the same place at the same time?
B.
B. You can't be here at this point and at this point and at this point all at the same time. Your distance from a home, it's like you're in 3 places at once, right? And then the last one would be D. And if you think of that last one, he gradually builds up speed, so he's going faster. Then he kind of goes the same speed. Then he goes faster again as we are looking at that one. Please make sure you have those written down. As you look at the next page in your notes going down, as we look at this last page of notes, it says Sylvia bikes home along a straight road from her friend's house, a distance of 8 miles. The graph shows her journey. So this is starting 8 miles from home. This is when she gets home. So we can tell she got home in how much time? 90 minutes, hour and a half. We're asked to describe what happened, include the details of how fast she is going. So what we want to start with as we are looking at this. So I'm going to have you write down kind of all this that I'm writing down if we are looking at this. So we're going to say she starts where?
8 miles away.
Starts 8 miles from home. Please write. 8 miles from home. That's our first piece of information. We're going to call these different parts of the graph. We're going to have this be part A. This is going to be B, C, and D. Okay? So that when you're describing it, similarly when we take our test on this unit, you are going to be asked to show or explain all the different parts. So if we are looking at this at part A, so first off, we want to say at part A, how fast are we going? She's going towards home, right? Bikes toward home. So we are going how many miles? 2 miles, right? That's going down 2. So we are going 2 miles in how much time?
30 minutes.
30 minutes. Do we want to go miles per hour if we're biking, or do we want to go miles per minute?
Miles per hour.
Here we either have a choice. We can go in 30 minutes, right? And we can find miles per minute. Or we can go 2 miles in half an hour. If we go 2 miles in half an hour, 2 divided by a half is
1.
2 divided by a half is the same as 2 times the reciprocal of a half is 2 over 1. This comes out to be 4 miles per hour. If you need to put this to help you remember how to find, write that on your paper, okay? Would you say this is a positive or negative slope? Negative. So when we think about those 2 miles, we were going down 2 for half an hour. So I like better telling us that we are going negative 4 miles per hour. Bikes home at 4 miles per hour. Make sure you have that all written down, Hunter, okay? We're going to go to B now. At part B, what's happening at part B?
She took a rest or something.
She's taking a rest, right? So she's resting for 10, 20 minutes, right? So her speed is 0 miles per hour. That's our slope, right? 0 is a horizontal line. Anytime we are going 0, horizontal line, okay? So let's look at part C. Part C now tells us we are going how fast? 1 mile in 10 minutes. Are we going towards home or away from home?
Away.
Okay, so she's riding away. Why might she be riding away? What happened? She rested and she realized what? She realized she saw, maybe she wanted to avoid something, right? So she's still going away from home. So riding away from home, if we are thinking about that. And we said she went 1 mile in 10 minutes. What is that going to look like? If we take 1 and we divide it by 10 minutes is how much of an hour? 10 60th is 1/6, right? So 1 divided by 1/6 means how fast are we going? Are we going faster than earlier? Because this is going to be 1 times the reciprocal of 1/6, which is 6 over 1, which gives us 6 miles per hour. So we're going faster now, right? So we started going towards home at 4 miles per hour. We rested for 20 minutes, going 0. Now we're going faster. And now for this last stretch, D. At D, she is going to ride home at, this time we want to take a look. We are going from 7 down to 0, right? So a negative 7 miles. In how much time? 10, 20, 30. So again, in half an hour. Kind of like we did here. 2, here we're going to have 7 divided by a half. So that's going to really be negative 7 times 2 over 1, which gives us a negative 14 miles per hour. So all of a sudden she realized she had to be home at a certain amount of time, so she was going much faster, right, than she did before at 14 miles an hour. Okay? So when on page 32, because there's so many graphs and it kind of takes a lot of pages, make sure you take a look at what's on your axes. So the price per gallon and the quality, time in seconds, distance, number of meals and the profit, height and time. I would like you to turn to page 33 and look at number 7. I have some people, when they look at number 7, not sure how to figure this out. But the key thing up here is this is one piece of information. So when we read that, it says, the time it takes to ride a bicycle 100 miles is a function of average speed. So we know that we are going 100 miles, right? So if you go 5 miles an hour, how fast are we going? At 5. So go up in number 7 from 5. Right? Now 5 isn't listed on your graph, but if this is 10, we are at 20. And you got to put a label with that, hours. So it says, how long does it take you? Some of you haven't written that yet. You should write that one in. 20 hours. So 20 times 5 gives us what? 100. So when you look at 10 miles an hour, at 10 miles an hour, how many hours? 10, right?